and welcome everyone to IATM Insights, the virtual webinar series presented by the International Association of Technology and Management. And we are excited to have with us Dr. Masood Siddiqui, who is professor and ex-head of the Department of Statistics at the University of Lucknow. He previously served as Dean of Research, Pan Area Chair in Decision Sciences and Analytics at Jaipura Institute of Management. He also has an administrative experience 3 years as a Class 1 officer in the state government. He has been associated with Great Learning as well. He holds a PhD in mathematical statistics and was a CSIR UGC Fellow in Mathematical Sciences. His area of expertise is machine learning and deep learning, data science, econometrics, multivariate data analysis, optimization, and more. He has wide experience of consultancy and also has taken more than 300 FDPs, MDPs in various areas. He has co-authored the well-known book Statistics for Management with Pearson Publications, and he has more than 60 research papers to his credit in various internationally acclaimed journals as of today. He holds 3 Indian patents and 1 international patent has been granted to him. So we are certainly excited to learn from such a distinguished individual today. And thank you again for being part of the IATM Insight series. Dr. Siddiqui, it's
Thank
all
you. Thank
yours.
you, Dr. Doran. And thank you, IATM, for giving me opportunity to share the concept. I am sharing the screen. So I will be using the dual screen. So whenever some issue is there related to the sharing part or the compatibility part, kindly indicate. So as it has been mentioned that what we are going to do, as the first topic, we are going to discuss the linear regression analysis. Now, how will we will be proceeding? Just a case has been shared that is related to Procter and Gamble Pampers. So we will be discussing the case, right? What is the business requirement? What type of analysis is required? And then we will be moving to the analysis of the case using this concept of regression analysis, right? So we will be doing this situation. So I am just changing my screen and I am coming for this screen. So now, this is the case that I have just shared. It is related to Procter and Gamble Pampers. It is actually broadly taken from the book Marketing Research by uh, Naresh Malhotra and Satyabhushan Das. It is from the Pearson publication, 7th edition. Right. So, the initial part of the case is related to the very popular and high market product, that is the diapers, right? And traditionally, there are two main players or the two main competitors. One is the Procter and Gamble's that introduces Pampers, and other one is the Kimberly Clark that produces Huggies. Just a moment, let me clean. Okay, right. Okay. So this is the situation, and this case is being written from the perspective of the Procter and Gamble that produces Pampers, right? So since this is a FMCG product and it is highly competitive in nature, so whenever the product or the services are competitive in nature, then obviously the role of the customers or role of the consumers becomes very important. So this product is related to the baby diapers. Obviously, the consumer are too tiny to give some feedback. So here the we will be discussing the concept through the perspective of the customers, that is the mothers, right? So, what is the objective? As in the third paragraph, it has been mentioned that Procter and Gamble marketing department wanted to formulate new approaches to the construction and marketing of the uh, Pampers, right? And since customer is very important in the competitive market, so they have taken the feedback from 300 mothers. So what is being given to each mother, so each customer, uh, a particular brand of the diaper or pack of the diaper is being given, and that has been asked to rate the diaper on the 9 attributes and overall preference. So there are actually 10 features are here. One is the overall preference and there are 9 diaper attributes, right? So they are been they have been asked to give preference or the rating on a scale of 1 to 7, where 1 is the least preference and 7 is the highly preferred. In the same way, the 9 diaper attributes are in 9 diaper attributes has also been taken on the same scale, right? So 300 is a sample size, and what is the goal? So the goal of the study is to learn which attributes of the diaper were most important in influencing the purchase preference. So this is the task in front of us. And just to show you, you people are having the case. These are the 9 diaper attributes. These 9 diaper attributes has been suggested by the Procter and Gamble marketing department. So they are being considered as important in making the decision of whether the diaper they are liking or not. So this is the situation. And so first I will be introducing the concept through this case, and then we will be moving what is being required, right? So now, as it has been mentioned that there is an overall preference. So we are having the overall preference. So there is an overall preference, right? And here we have 9 diaper attributes. And it is being expected that these 9 diaper attributes may be responsible for uh, rating the overall preference. Mean maybe the overall preference may be high because of these 9 diaper attributes, or overall preference may be low. So this is the situation. So just for the conventional purpose, we can denote this overall preference as Y, and these 9 diaper attributes are being denoted as x1, x2, xn, right? So if we go further to this case, so what we observe? We observe that uh, a type of a dependence relationship has been examined. So there is a dependence relationship. Mean it can be considered that this overall preference may be dependent upon these 9 diaper attributes. So we can say this y may be taken as a function of x1, x2, xn, right? Even if we don't have the background of the mathematics, functional relationship means these 9 diaper attributes may have some impact on the overall preference or the y. It has been thought, right? If we go further to this description, what we observe that this y is rated on a scale. So since this is rated on a scale, so it suggests that this is numeric in nature, right? This is numeric or metric in nature. And these 9 diaper attributes are also rated on a scale, whatever the scale is. So they are also being taken as numeric in nature, right? So in this situation, since y is numeric in nature and we are considering a dependence relationship, right? So we can take this as a case of regression analysis or the regression model. So we are expecting a regression model in this situation as per the description of the case. Further, right, for the time being, we can assume that this regression model is linear in nature. Right? So it can be termed as linear regression. So we are expecting a linear regression model. So this is the situation. So we can say that this y is the overall preference, right, which is a linear function of x1, x2, xn. It can be expressed in this format like beta 0 plus beta 1 x1 going up to beta 9 x9, right? Means this y is a function of x1, x2, xn. So we have put certain coefficient. Later on, we are calling this coefficient as the regression coefficient. And we are introducing one more term, that there may be some other factors also that are outside the model that may have some impact on overall preference. Obviously, here we are considering the 9 diaper attributes which are being suggested by the Procter and Gamble. But it is highly likely that there are certain features which may not be considered through the literature review or through the uh, marketing department. So we will be putting this as an extraneous term, or that is the epsilon. So this model is technically known as the linear regression model. So we are going to study this model, right? Now, there are certain things, there are certain misnomers that needs to be clear. What do we mean by linear? Here we are having two terms. One are the regression. So these betas are known as, so these betas, beta 1, beta 2, beta 9 are known as coefficients. Or for the time being, we are saying them as regression coefficients, or they are being known as parameters. Why they are the parameters? That once we have the information about these 9 uh, betas, so we will be having the information related to our model, right? So the first concept is, what do we mean by linearity? So this linearity is with respect to the regression coefficient. So the linearity is with respect to regression coefficients or regression parameters. So what does this mean? That all the betas should have the degree 1 only, right? So remember, if we put this model y equals to beta 0 plus beta 1 x1 square, it will be linear, because here the regression coefficients or the parameters are linear in nature. But if we write, then this will be non-linear. And so this is the misnomer. Means here the linearity is with respect to the regression parameter or the regression coefficient. So we will be discussing this model, right? So now I am introducing the concept here, right? So what we discussed on the first slide, we can putting them in certain words. So this is the dependence associative relationship. What is the dependent associative relationship? It is the relationship, like here it has been mentioned, that this y, means we have taken this model y equals to beta 0 plus beta 1 x1 going up to beta 9 x9 plus the unknown part, or the extraneous part, or the external part, that is also known as residual part, that is the epsilon, right? So this y, if we say the language of statistics, so this y is known as dependent variable, and these x1, x2 are known as independent variables. So here the dependent variable must be single. Independent variables may be single as well as multiple. If we have the single one, then that is known as simple linear regression. If x1, x2, xn are multiple, then that is known as multiple linear regression. There are other terminologies also, like if we go in the language of econometrics, so this y is known as explained variable, and these x's are known as, these x1, x2, x9 are known as explanatory variable, because we are explaining y in terms of x1, x2, xn. If we go in the language of machine learning, this is known as response variable, target variable, and this is known as features. And if we go in the language of time series, or even for the machine learning, that is known as predicted. So this is the predicted variable, and these independent variables are known as predictors. So there are these synonymous terms that may be used so to denote these terms as per the requirement, but everything remains the same. So this is the first thing. So what we consider a dependence relationship, right? So dependence relationship means the relationship is from independent variables to the dependent variable. So it has been mentioned that we consider the dependence associative relationship. Associative relationship means the regression analysis studies only whether there is association or not. It never gives us the causal relationship that we will be discussing later on. And there are different terms also, like this is also known as supervised learning. If we say the language of analytics, so this is known as supervised learning. Why this is known as supervised learning? So this is known as supervised learning. Why this is a supervised learning? Because we have the labeled data. So labeled data means we have Y and we have some X features, right? So we have the label data. That's why this is known as supervised learning. At present, here we will be discussing more from the perspective of the marketing research or from the perspective of the statistics, and less from the language or the lingo of analytics. And that will be we will be doing when we discuss this through the Python or machine learning packages. Then in that case, our language or the lingo will be strictly in the terms of machine learning part. So anyway, so this is the to analyze the associative relationship between single dependent variable, this we have discussed, and single or multiple independent variable. If the independent variables are single, so that is known as simple regression, and if otherwise, so that is known as multiple regression. Right? It has been mentioned. And here, the important thing is the data must be metric or appropriately transformed. Appropriately transformed means we will, if x's are, so if x's are non-metric. Non-metric means if they are categorical or object in nature, then we use dummy variables. So at present, we are not discussing the dummy variable. The dummy variable part will be discussed when we discuss through the scikit-learn package, right? And the purpose of the analysis is twofold. One is the prediction. Prediction means we want to predict the value of y. We want to predict the value of y. So let us denote as y cap. And other is the explanation. Explanation means the importance of axis, means which x is important and which x is not so important. So there are twin objective. One is the prediction. In the machine learning, we are more concerned with the prediction. And in the case of marketing research or marketing analytics, we are more concerned with the explanation. So it depends upon the domain for which we are going to apply this regression part. So this is the model that we discuss. Now, we are discussing this model in a bit more detail. Like we have mentioned this part, right? So what is the objective? What is the objective of the regression analysis? As far as statistics is concerned, we want to estimate the model. Estimate the model means we want to estimate the parameters. So here the parameters are the betas, like this is the model, right? So how this model is being estimated? So I am using here. So this model may be estimated using these estimates. So beta 0 may be estimated by B0, beta 1 may be estimated by B1, right? And in the same way, this B9, beta 9 may be estimated by B9. So these B's are the estimated coefficient. So earlier I have mentioned these betas are the parameters of the model, right? So I am writing that again just to reiterate. So these betas are the regression parameters. And these regression parameters are unknown, right? And they are being estimated empirically through the data and and through the estimation, what we get these B's. And these B's are the estimates. These are the estimates, right? So our objective is this one, right? And one more important concept that is needed to be mentioned, that once we have um, the model run, so this part is completely known, right? So this is the known part. So this is the known part. So known part means we know everything about this. So this is the known part. Known means this is the deterministic part. And the other part is the epsilon that is outside the model. Since this epsilon is outside the model, because it represents those terms that are not directly observable, that are not through the model. Since it is outside the model, so it is unknown. So unknown means we consider them as random in nature. We consider them as random in nature. So let us come to the model again, right? So here, this y, right? So this y is actually, this is the part like beta 0 plus beta 1 x1 going up to beta 9 x9. And the other part is this unknown part, that is epsilon. So as we have discussed in that slide, so once we have these estimates, so this is the known part or the deterministic part. And this is the unknown part or the random part. Now, since this y is the sum of known or deterministic as well as the random part, so this y is also random in nature. So what do we mean? That this y can never be estimated fully, right? So y is also a random variable, y can never be estimated fully. And since y can never be estimated fully, so it means this only the average value of y may be estimated. So in the language of the statistics, we say that we will be estimating the expected value of y. So this is a statistical relationship, not a functional relationship. What does this mean? We can never get the exact value of y. So y will always be average in nature, right? So this is an important concept, right? That's why there are other type of regressions also, like apart from the apart from the regression, we also have the quantile regression where we estimate the quantile. So here it is only the average value that is being estimated, right? And one very important thing is that this is a regression model, does not establish the causal relationship. It it is only the associative relationship. Means it can never say if we have the substantial regression that it will be a cause and effect model. It will always be a associative relationship. Let me take an example so to discuss this uh, um, what this concept means, right? So I am taking an example. Suppose we have calculated data on the two variables. One is death because of drowning. So one feature is death because of drowning. Right? And other is ice cream sale. Right? Suppose we visualizing a regression model and we term this as a y variable and this ice cream sale is being termed as x variable. Now it has been observed that whenever ice cream sale are high, the death because of drowning is also high. When the ice cream sale is low, then death because of drowning is also low. And when ice cream sale is moderate, then death because of drowning is moderate, right? So means through this discussion we can say that we are expecting a substantial regression. We are expecting a substantial regression, right? Means all the regression parameters that are required are substantially high. So can we say that this death due to drowning is because of ice cream sale? Means we are mentioning that this ice cream sale is the cause and death is the effect, right? Because a high level of regression is we are expecting. So obviously anyone can say that this is an absurd analogy, right? So even if the regression is high, so we are not sure that there may be cause and effect relationship. Why it happens? Because here, as we see this death because of drowning is a function of temperature. Means when the temperature is high, more and more people go for the swimming, and the chances so many people are in the river, pond, or the sea. So there are higher chances of death. And whenever the temperature is low, so less number of people go for the swimming, so the chances is less. In the same way, normally when the temperature is high, so ice cream sale will also high. So here the ice cream sale is also a function of temperature. So whenever the temperature is high, ice cream sale will be high. And whenever the temperature is high, uh, more and more and more people go for the swimming, so number of death because of drowning is high. Whenever temperature is low, the winter days are there, so ice cream sale is low. And in the same way, less number of people goes for the swimming, so there are less chances of death. So here, because of some extraneous factor, that is the temperature, which is affecting both the features, and it is giving us the impression that there is a uh, causal relationship. So what is the purpose of this discussion? That even if substantial correlation, substantial regression is there, we can never be sure that it is because of cause and effect. It may be because of some other reason also. Okay. So this is the concept, means regression or correlation can never gives us the causation. Right. So now, so hopefully these concepts are okay. So these are the, now we are discussing what is being done in the regression analysis. So here um, we consider the appropriate problem. We go with the selection of dependent variable as well as the independent variable. There are two in objective. One is the prediction we discuss, means we predict the estimated value of y, and other is the explanation, means which coefficient is high or which coefficient is low, right? So it is a statistical relationship, not a functional relationship. And whenever we propose the model, there should be enough study uh, in the support of the theory. So the role of the LR or role of the literature review is very important in this situation. So we will be going only if substantial literature review support is there, right? I mean, there should be some evidence before that. So this is the, now we come to the research design part. It is a large sample, so Sample size, because this is a large sample problem. So we always go that the sample should be large, right? This creation of additional variable we are not considering for the time being, right? Now, before moving forward, let us discuss what are the possible steps or what are the questions that need to be answered for a regression model. So here we are discussing related to what things are required for the estimation or the study of the regression model. So we are considering the steps, right? So here, what is the first step? We examine whether there is a relationship or not. Means the first question that needs to be answered is whether there is a significant relationship or not. Means whether the predictors that are being considered here are significantly associated with the y, right? So obviously, means in the technical term, this is known as whether our regression model is significant or not, right? So there are two questions. If the answer, two answers are there. If the no, means a relationship is not significant. So we will be looking for other features. Means if we will be getting insignificant relationship or insignificant regression model, means there are certain other features that are impacting the y variable. So we will be looking for other features. And if the answer is yes, so we will be proceeding to step 2. So obviously this case is being constructed for the demonstration purpose. So we are expecting that we will be getting yes. But in the study, we can get yes as well as no. So if the answer is no, so we will be looking for other features. And now if there is a significant relationship or significant model, right? We will be going for strength of the relationship. Means in the other form, we can say we will be going for strength of the regression model. Now, up to the second stage, we are considering all features in one go. Means we are not, means we will be considering the bucket of all the features. Like here we are considering the bucket of 9 features. But it is not at all required that if there is a significant or a strong relationship, then all the features are contributing. So in the next step, we look for what features are significant in nature. So we will be looking for significant independent variables or significant features. Means it may be possible if the relation is insignificant, then obviously all the independent variable, all the features will be insignificant. But if the relationship is significant, so it may be possible that at least one, maybe all are significant. It may be possible that only one is significant, rest are not, but on the other side, all 9 may be there. So there may be any situation in between them. So we will be looking for significant independent variable. After that, the next step is if we get only one significant predictor, then that's okay. But if we are getting more than one, then we will be interested in which one is the most important one. So we will be looking for hierarchy of significant features or significant independent variables. Then we generalize the result. So generalization of the result means we propose a model. So why we propose the model? We propose a model for prediction purpose. For prediction purpose. So these are the 5 steps that will be covered in any regression analysis. Deliberately, I haven't mentioned the first one, right? So let us put at 0. So this is because this regression model is estimate or the estimation technique is a particular one. It is known as ordinary least square or least square estimation or classical linear regression model. So we will be requiring certain assumptions. So actually the initial step is checking assumption, but I have put it as 0 because it is not part of the model, but the model is to be considered or not. So for that purpose, we will be discussing the assumption. Now, normally we believe that only the software will be running the analysis, software will be giving the answer. Assumption doesn't hold that much importance. So for this purpose, this case is very good. I am taking up this case without discussing the assumption, and you will be getting a somewhat absurd result, right? So deliberately we won't be discussing the assumption in the first quote, but I am showing you that these are the assumption. So these are the assumption. So at present we are not discussing the assumption. We will directly be going for the analysis purpose just to demonstrate the role of assumptions, right? So in the first part, we will be ignoring the assumption. And when we get some absurd type of result, then it reiterates, it establishes how important the assumption is, right? So now we will be proceeding forward. So before that, let me run the case, right? After that, we may have the discussion. Okay. And whatever we are discussing, so it is there in the further slides also. Like here, you can check that it is in the slides. Everything is being there. And also for the new users who have no experience in the SPSS, so these are the screenshots how we will be doing, right? As I have mentioned that today's session is based up only upon the SPSS. So I haven't included the machine learning libraries like scikit-learn or stat model, right? That will be done later on. So I thought don't mix. So here through the screenshot, you people have the idea, means how we will be reaching to this analysis, right? So hopefully the things are okay up to this stage. Should we move forward?